Hello and welcome to this Meet Your Future session. In these sessions we hear from people in different roles and you have the opportunity to ask them your questions about what they do and how they got to where they are. My name is Jamie Sloan and I'm your host today. I work at the Greater Manchester Combined Authority and I'm here in the GMCA offices this morning. It's my job to help young people find out more about the different careers and options that are available out there to them. One of the ways that you can do that is on the GMACS website, gmacs.co.uk, which has lots of information for young people who live in Greater Manchester. Today, though, as part of Women in Engineering Week, we are going to hear from Rachel Bennett, who is an acoustic engineer with Ramboll. She's going to be telling you exactly what that means, what she does in her job, and how you can get into it. If you've got any questions, please do put them in the chat and we will have some time to answer them at the end. You can also turn on live subtitles by selecting turn on live captions, in the menu. I'm now delighted to hand over to Rachel Bennett and I'm just going to remind her to unmute before she starts talking. Thank you, Rachel.
Hi everybody, good morning and thanks for joining us today. My name is Rachel and hopefully you can see my screen. Let's see how we go. There we are. So I'm an acoustic consultant with Ramboll who have offices all over the UK and globally. Local office to you would be Manchester and I do work there occasionally. I'm an acoustic engineer and I found the most stereotypical photo of me I can find in a hard hat. And today I will be talking to you about a few things. So the first thing, what exactly is engineering? We'll have a little think about that. And then what kind of engineers are there? Because it's not just me, you'll be glad to know. What do I do specifically? If you've had a chance to have a look at some of the material that was sent round beforehand, we can have a look at your soundscapes. Very quickly introduce you to a competition that's running at the moment that you might want to join in. And then we'll have some time for questions at the end. So this is what we're going to talk about today. So first things first, I don't know if you've had the chance to think about what is engineering? What is an engineer? What might they look like? If you think about an engineer, what's the first thing that pops into your head? So I did what anyone else with a question would do, and I Googled it. What is an engineer? And these are the first set of images that come up. Lots of hard hats, lots of high vis. It's a fairly good mix of men and women here. They're mostly white people. They're all about a similar age. They seem to be on buildings. Is that what you think of as your stereotypical engineer image? Which is true, these people are engineers, of course, but it's not just that. And I'd like everyone to open their minds to what it really is and what it includes, because it is so much more than wearing a hard hat. I've got one, but it stays in the cupboard most days. So the next image I have is a little bit biased because it is from the Women's Engineering Society, so it's mainly women, but this should give you a little bit more of an overview of what engineers do, what they might look like. So we've got people in healthcare settings there, we've got people outside, we've got people inside, a lot of work in offices, all over the place. So it's so much broader than a building site and a hard hat and a hammer. And yeah, hopefully by the end of this presentation, you'll see a little bit more about what that involves. So engineer. We have a problem with the English word engineer because that's what you think of. Well, that's lovely. That's not what it means. It actually comes from the word ingenuity. And if you speak any other languages, that might be a little bit more obvious to you. So think about ingenuity. We're not all working on steam trains, you'd be glad to know, a little bit outdated. If we looked at a really dry kind of dictionary definition of engineering, we have a couple of things here. So it's kind of applied science and technology, or the action of working artfully to bring something about. So in my opinion, I think there's both. It's very, very broad. So engineering is the application of science to the needs of humanity. Now just let that sink in for a second, because that's quite a statement. Application of science to the needs of humanity. That's huge. The needs of humanity. That's everything, right? What can we do? So looking at it, it's application of mathematics, fine, and science, practical experience, possibly more so than your theoretical knowledge, and the design of objects or processes. So this is a really, really broad subject, and it is the application of knowledge of what you've learnt, but more so knowledge of the world around you and your kind of life experience and how you can apply that to improve the life of everybody all over the world. So it's huge. It's absolutely huge. So going from there, what kind of engineers are there? If it's not just people on a building site, what is it? Any ideas? I have pulled up some of the most common ones, but there's far, far more than this. So yes, there are people who do design buildings, excuse me, and infrastructure, also software. We're looking into biology and chemistry, manufacturing, all sorts of different things, far more than I could go into here. And you know, a quick search will find you, you know, if there's something you're interested in, there will be an engineering discipline that covers that. It's really is for everybody. So why am I talking to you about this today, particularly? Well, on Thursday this week, it is International Women in Engineering Day. So this week and throughout the whole week, we're celebrating that. But why is that a thing? Why does that exist? So this data I have is slightly out of date, but the point still remains, is that in the UK, only 11% of engineers at the moment are female, which is tiny, and that is the lowest in Europe. So why is that? Does it have a bit of an image problem? Who knows? So hopefully just kind of sharing some information with you, kind of open that up a little bit, and hopefully, you know, realise that it really is for everybody. It isn't just kind of a male dominated space. And why is that important? Well, most engineering employers saying that there is a shortage of engineers, and that's a threat to their business. And as you see, in engineering is involved in absolutely everything. So this is a problem, and there are so many opportunities for employment within this. So really something to consider, even if it's kind of not crossed your mind before. You know, have a look into it and see what there is there for you. Okay, so we've had a little think about that, but what do I do? What do I do? Well, as you've heard, I am an acoustic engineer, and a lot of people might be thinking, what on earth is that? So if I turn to the dictionary again, not very exciting, but the very boring definition is the study of the generation, transmission, and reception of energy in the form of vibrational waves in matter. You're thinking, what? Okay. But professional acoustic engineers, consultants, we look at all sorts of different ways that noise and vibration travel. So that might be to do with energy and wind farms. You know, if you've been near one of these turbines, they make a noise. So how is that going to affect everybody? We look at internal spaces too. So recording studios are a classic example, but this can be any building you can think of, how sound travels in that building, how that affects people. Other people are looking at noise, particularly with machinery and cars, and there's always somebody who's designed your car to make it sound wonderful. Looking at music and performance spaces, so that's somewhere where it might be really obvious to you, you know, you're thinking about the music, how that sounds. That space has been designed specifically to sound a certain way. Something a little more stereotypically engineering-y, if you like, building sites, things like that. You know, if you live or work or your school's next to one of these, you know, it's noisy, that's going to affect your day. So we work at controlling that and limiting the noise and vibration impact. And also electroacoustics, so things like loudspeakers and microphones, recording systems, all sorts of electrical engineering involved in that. And this is that's just the surface of this. So within any engineering discipline, there's not just one thing you can do. There's 100 different disciplines within that group of stuff. So there's always a way to find your thing. So many people ask me, like, how did I get into this? You know, how did I even find out it was an option? To tell you the truth, I didn't know it was an option. When I was at school, I'd never heard of it. No one had mentioned engineering to me, even though I really liked physics. It wasn't there. So one other main reason I'm speaking to you today is because no one spoke to me, and I would have really liked that. So when I was at school, my main subjects, I did a few, chopped and changed a little bit, but kind of landed with physics, maths and music technology. So I was really into recording music, bit of a frustrated drummer, really liked, you know, kind of live events and setting all that up. That was my thing. So from there, I went into music technology, and that's what I studied at university. So yeah, lots of live events again, lots of recording, looking at software, electronics, bit of a mixed bag. And from there, I kind of got into looking at loudspeakers and microphones and how they were made and designed. So that sparked my interest to go and study audio acoustics. And this was in Salford, actually. So some of you may have even been there. This room is generally where they test speakers or microphones or things like that. And all these funny wedges on the wall are there to make it as quiet as possible. Really interesting space. So from audio acoustics, we kind of got exposed a little bit to more about all the different things that are involved with acoustics, and got more involved in environmental and the building side of things. So I'm not just standing next to a river with a microphone, really. If you look in the background, there's a bridge here, and in this case, it's the Forth Crossing up near Edinburgh, and they're going to build a new bridge, which is open now. And we're looking at the impact there of the noise from building that bridge, and the local neighbours, and also the marine life within the water itself. So really different from my starting point of, you know, putting microphones on drum kits. And from there, I became an acoustic consultant. So I work with environmental things, and I also work with building design. So it really is different every day, and we do a little bit of everything. And for me, that's great because my attention span's pretty small. So if we do something different every day, then I'm happy and no one gets bored, and that's great. So if I think about a typical project that an acoustic consultant might do. So for example, if you choose a building, let's say it's a new block of flats. The first thing we do before you even put a spade in the ground is we go to where those flats are going to be built, and we will take a noise survey. So we'll go with a microphone and measure the noise levels in the daytime, in the nighttime, see what's there already, and that's our starting point, excuse me, for then designing the building. From there, we may build a noise model. So you can see the different colours on this map here. Perhaps a little bit like you see rain on the weather forecast. So the different colours will show you how loud it is across that site. And you can see, you know, is that a good place to put a building or not, basically, from a really high level. Shall we put it here? Shall we move it over there? If we put it here and it's noisy, are we going to need to put something there to try and mitigate that noise? So that's a really good starting point for the whole design team working on that building. And from there, we can start working on the design, building envelope. So that's basically anything that is the outside of that building that's stopping the noise getting in. So the roof, the walls, the windows, we design them so that the noise inside is a nice level. You're going to go to sleep without being disturbed, perhaps. Any traffic, any trains outside aren't going to bother you because that has been designed to make sure your indoor level's at a nice volume. So from looking at the outside of the building, we'll then go inside and we'll design all the walls and the doors and the floors inside that building. So, for example, you can't hear your neighbours snoring or watching the TV, or perhaps moving chairs and tables around upstairs. All of that will be designed to reduce that to a level that is acceptable to people in that building. That's an interesting picture. That is a spring. This here is a spring, and we've got a ceiling underneath. So M and E is mechanical and electrical noise. So, for example, if you've got some fans in your building or some pipe work or the plumbing, we look at that too, make sure we've not got any funny noise from somebody flushing the toilet upstairs or somebody's kitchen extract fan is going to bother you. All of that gets considered as well. And then we'll look at what's called room acoustics. Maybe not so much in somebody's flat because that is up to the person living there. But if you think about a concert hall is a really good example, or even a school, how well you can hear people within that space. We usually make a 3D model of that, which is what's happening in this animation. And the way we control that is by choosing the different finishes in that room, or even the shape of the room itself. So you might have a particular kind of ceiling that absorbs the sound, or you might have something on the walls that will kind of control that. So it's not so echoey, if you like. You can hear people speaking properly. And the requirements of that room depend on what it's going to be used for. Then eventually, this is where we get our hard hats on. Once the building is under construction, we will go and visit, have a look at what's going on, and we'll check, excuse me, we will check that it's being built as per the drawings. And at that point, it's a really good time to see, before everything's closed up and painted, you know, you can see the tops of the walls or how things are being constructed, and you can pick out any problems before they become a problem and they're easily fixed. And at the very end, as you can see, this is a finished room, and we go at the very end and we will test it, and we will make sure that it is meeting what it's been designed to. So in this picture, you can see this is a loudspeaker, a special one we use for testing, which is a dodecahedron shape. So it's got 12 speakers in every direction. And in this case, we will measure the sound going through the wall to next door. And if that meets what we said it was going to meet, then we get a big tick, and the building can be given to its owner, and you're off. So this is a kind of a typical process with any type of building we work on from start to finish. And for me, I really enjoy that because you're working on the project from the very beginning to the very end, and you can see its progress. You're working with architects, different engineers, all sorts of different people who are looking at all sorts of different aspects of this building, and no two are ever the same. So you're always learning, and that's really great. So a little bit more about the projects I work on. I mean, I've just described a block of flats, for example, but anywhere there's a building, there's somebody like me sticking their nose in and making sure that it's designed properly in terms of how the sound passes through that building and how it works for everybody. Generally speaking, if it works, no one notices. It's only when it goes wrong that people notice that there's a problem. So just a few examples. This is Headingley in Leeds. We were recently involved in the design of the new stand there. And you might think, well, that's outside. What's that got to do with anything? But in this case, it was the PA system that we were designing. So it was a case of making sure that everybody who was in that stand could hear the announcements very clearly. And it's the kind of thing you notice when it doesn't work, if you can't hear something properly, if you've got interference from another speaker and it all goes wrong. So there's lots of measurements and lots of testing in this particular project. Something completely different is design of a new airport. Now this is an architect's image, it's not been built yet. But again, airports are really interesting because obviously you've got the aircraft noise outside, which is really high, so you have to design your building so that that's not coming in. And within the space itself, it's usually a really large open space with lots and lots of people. So that has the opportunity, that can be really noisy if you let it. So it's designing the building to keep that under control so it doesn't get too noisy and chaotic, that you can hear any emergency announcements and then they're clear. So obviously in airport, security is a big issue. So lots and lots of things to consider there. And this is something you might traditionally associate with an acoustic consultant. This is the South Bank Centre in London. This is actually a refurbishment project of one of the halls. So if you look very closely, you can see how the walls are a slightly different shape. They've got some little holes in them. So that's all different kinds of room acoustic treatment to get the music in that space sounding exactly how you want it. And depending on where you're sitting, that can change. So the design of that was to control it so that no matter which seat you've booked, you're still going to get a really good experience. Also in this building, you've got the tube running underneath it. So it's a case of how do you control the noise from the trains underground underneath your concert, disturbing that. So that was really interesting. This is the image I showed you straight to begin with. This is the new fourth crossing. So this is a road bridge. The one in the middle was the original road bridge, which is starting to fail. So they've replaced it. And you might think, well, what's noise got to do with a bridge? Obviously, you've got the traffic going over it. So it was a case of making sure that any increase in traffic isn't going to upset neighbours. So there was lots of monitoring going on. But the main thing for us in this case was actually the marine life. And to construct this new bridge, there was lots of blasting in the river, lots of explosions, and the effect that may have on any kind of marine life there. So again, lots and lots of measurements, lots of monitoring, and keeping that to a controlled level so that it was all okay, if you like. So that was a different thing again. And finally, something that I guess you're all familiar with, schools. I do work on a lot of schools. And again, it's something like if it works, you don't notice. But if you're in a classroom and you can't hear your teacher properly, or you've got noise from the class next door bothering you and interrupting what you're doing. I don't know, if you're near a busy road and you open the window and all the traffic noise comes in, that's a problem. So all different things here. Sports halls are a great example. If you're in a sports hall, a huge space, and you're bouncing a ball and you're trying to hear the teacher, sometimes that's really hard to hear in a massive space. So it's how you control that and make it a bit better. And we work on new schools and also refurbing old schools to improve the acoustics there. We do a lot of that. So just a very quick sample of the different things we do, and there's much, much more. Okay, so I don't know if anybody has had the chance to have a look at some of the things that we sent around before this presentation. But it's just a bit of a thought experiment really about soundscapes, having a think about the world around you and what you can hear. And I think the example I gave was perhaps a walk, a short walk you may take on a regular basis. So for example, maybe you'll walk to school or college or work, the different sounds you hear around you, whether they're sounds you like, whether they're sounds that bother you, and kind of have a think about how those fit together throughout your journey. This was actually taken from a competition we ran last year. So, I mean, it's very specific about the length of that walk, but doesn't really matter as a thought experiment. But how would you describe that? And how could you think of a map about where you were? So, I mean, there's a few pictures of different examples here. So have a think about what you found. What was that about? How did you find that? Perhaps we can discuss that in the chat a bit later. But the question that I do get asked is, well, who cares? I walk to school, so what? I can hear a car, so what? But again, if it doesn't bother you, you don't notice. It's only when it does bother you. So for example, I've just lost my slide. There we are. So nighttime noise, even if you're sleeping through noise at night, it does affect your sleep quality. It increases your stress hormones, and then that will have an effect on your overall health. I think there's been links found between nighttime noise and an increase in blood pressure and effect on everybody's health. So something you might not notice, but if you're sleeping in a noisy place, that will have an effect on your health. Effect on places like, do you want to be in this space? So for example, if you're in a railway station, you've probably been in this situation. There's been an announcement. You don't know what that said. You don't know where your train's going from. It might seem trivial, but if you need to get a train quickly and it's going on another platform, you need to know, don't you? So just simple things like that. Is it a really nasty place to be in and you want to get out there straight away? Who cares? Classrooms, education. If you can't hear your teacher, or your teacher's having to raise their voice, they get fatigued, you lose interest. It's having an effect on people's learning, and it can really slow things down. So if it's a very noisy place or you're getting disturbed by your class next door, it's a problem. It's a problem that can be fixed, and it can make everybody's life a little bit easier. Spoke about it a little bit earlier, but noise pollution and wildlife. It does actually have a big impact, and I think there's been research into the impact on different birds and sea creatures. It's affecting the way that they communicate with each other. It's affecting where they decide to live. So, you know, it can be a problem, and it's something that we need to consider. Slightly odd picture. This is a picture of a hospital. Noise in hospitals, big problem. It's been shown that if people are in a noisy situation, then that really affects their recovery time. You think about the noise of all the equipment there. There's people working 24/7. So if you need to sleep and somebody's on a night shift, you know, it really can affect the recovery time of patients. So again, something that can be designed out of a space and really affects the people who use it. So this is why, I mean, why there's 100 reasons why. I have a thing here. Let me see if I can open this. So there's one for primary schools, which I'm guessing isn't relevant, but one for secondary schools. I think it's a good thing. It's you can get involved with the measurement of sound yourself. It's a case of downloading an app to your phone. And there's a competition here. I think there's prizes to be won and some sort of presentation. So let me see. This is a little clunky, I do apologise. I realise I could have had this open at the beginning and it would have been much better. I'm sorry. Are you there? We are there. Fantastic. So it is a case of using an app on your phone. You can go around and take some measurements. So it kind of ties into the soundscapes we were thinking about a little bit earlier. And it's a case of having a think about how you can measure something as accurately as possible. You know, what kind of different things would affect your measurement and give you a different answer. So there's no correct answer to this. Again, it's more of a thought process and you thinking about, you know, the whole process of measuring the sound and why. And there's a lot of words here, but if I leave that link up in these slides, it's something you can look at if you think it's something suitable. And it's something everyone can get involved in. It's really straightforward and kind of a bit of a science experiment, if you like. So I will leave that there for you. Let me see if I can get back to my presentation. Excuse me. So I'm going to probably run through that very, very quickly. But if there are any questions to go through, or if you wanted to discuss any of your soundscapes, then it's a great time.
That's wonderful. Thank you so much, Rachel. Did you say that you had a video that you wanted to share?
I did have a video. Maybe that's a good time to show you that. That was in my presentation. I don't know why it didn't pop up. So it is a 3-minute video.
Yeah, let's have a look.
If we have time for that, that would be really good.
Absolutely. Absolutely.
I'll share that screen.
Yeah, we got that. Thank you.
Perfect.
Order. Alexa, play some rock music.
Wow, that's really, really interesting, Rachel. The video seems to have stopped. Okay.
Here we go. Just for suspense. Institute of Acoustics is a great place to find more information as well, if it's something you're interested in.
That's fantastic. Thank you so much indeed. Thank you, Rachel, for your
Want to see that twice.
for your presentation and for your that video. And that's fascinating, really. Just I don't, like you say, you don't notice noise management when it's working well. But I was actually quite surprised at just how important it is, and all those stats at the end there of the video were quite surprising, really. I actually used to work in a job which had some quite poor noise management, and it was horrible. I couldn't think. It was so noisy. It was really, really tough to work there. So I guess my first question is, and this might be a little bit of an odd one, but given that when it's working well, you don't notice it, is it hard to get job satisfaction in what you do?
I don't know, because I notice when it works. Maybe because it's something I think about all the time. But you know, a lot of the times we'll go and take measurements at the end of a project to make sure that it is meeting the design. So you know, you've got those numbers that have come out of those measurements, and you can see, you know, did we do it right? And you know what you're listening for as well in that case. So, for example, you know, if you're in a performance space where there's music. I've been to performance spaces where I've been involved in the design and then later gone and seen a concert there, and kind of listening to that, and you're hypercritical, but you can kind of go, yeah, that worked, or oh no, maybe that didn't. But then you learn from that for next time as well. So yeah, I find it really satisfying. things like airports, and then you'll go and take a flight from there later, and you're up there looking at the ceiling going, well, did they do that right? And but again, I don't know, I find I notice it when it works because I've been thinking about it all day, every day. So yeah, certainly when you're involved in it, I think there's a great deal of satisfaction in knowing something that you've been involved in, that you've designed, is a place you can go and visit, and really see that in action, or hear it in action, I guess.
Yeah.
Yeah.
That's wonderful. And just wondering about how you got involved in sound and acoustics. Did you always have an interest? Were you interested in music, or were you musical as a child? Did you play an instrument?
Always loved music. Yeah, always been a big music fan. Very mediocre musician, but always had good fun playing music with friends. And I guess it was from there, when people started putting on gigs and things, I'd always be the one who'd be setting up all the equipment and plugging stuff in and fixing stuff. And always kind of liked physics as well, and finding out how things worked, or kind of more importantly why they didn't work and how you can make it better. So yeah, kind of got into it through there. And the maths then followed later. I think I was never really kind of excited about maths, on its own. And it was from physics and realizing that if I want to understand that, I need to kind of understand the real fundamentals of that, which is maths. And once that was applied to something that I was really interested in, then that made that in itself really interesting. So yeah, don't write stuff off straight away if it doesn't immediately spark your interest. You kind of later find out that actually that's really useful. And in my case, I kind of went backwards a couple of times to catch up on stuff before moving forwards again. So yeah, don't let stumbling blocks put you off.
Well, that's really, really interesting, and I wonder if we can delve into that a little bit more, because obviously it's Women in Engineering Week, and maths can sometimes be a barrier for some people, especially for girls who think that it's not for them, that they're not good at it. And so what would you say to someone who was struggling with the maths element of it?
That's a good question. I know a lot of people have asked me, like, why aren't there many girls doing maths? And I'm like, well, I don't know, because I did it. So it's really, I'm not sure. But I have been, when I was a student, I was working as an assistant in maths summer schools for people who really had struggled with it. And I think a lot of it is a barrier that you get it in your head, like, well, I can't do it, and you switch off. Or, what's the point? I'm never going to use this. Why do I need it? And I certainly found myself in that position a few times, like, oh, why am I solving this equation? I don't care what X is in this equation. Until you do, until that X is something that you want to find out. I need to know, for example, I want to stop this bridge from falling down. So I need to know how heavy this is going to be, and that's X. So I want to know that. That's interesting to me. And suddenly then it kind of all slots into place. I don't know, I find, I have problems with numbers. I'm not an amazing mathematician at all by any stretch. But I think it's finding what you like and what interests you. And that gives you the motivation to kind of get your head around some of the stuff that you might have found difficult. But don't let your first experiences put you off. There's always a way of learning something that suits you, I think.
Thank you for sharing that. I think that is that's really wise words, and I think a lot of people find that helpful. Thank you. Kind of sticking with that theme for a moment, some people think that jobs in science and engineering is for clever people, and people might not consider themselves as clever, so they might not think that these roles are for them. So do you consider yourself to be a clever person? Do you think that your colleagues that you work with, do you think they are clever people? Just wondering if you could talk about that for a moment.
I don't know. I mean, what is a clever person? I mean, does that
Exactly.
mean that you've got loads of certificates in something? I mean, I think especially with engineering, you know, obviously there's a part of it where you learn the theoretical things and you've got this understanding of the theory, but much more of it, and especially as you progress through your career, it's all based on experience and your life experiences and kind of what you've learnt on the job. So I don't think it's not necessarily, you know, what were your grades like? I was never a straight A student at all. I passed things, I got my head around things, but it's kind of how you work through problems more than anything, I think, for engineering especially. And I think it's really important that people come from different backgrounds too, because if everybody's done the same course, the same degrees, been to the same university, comes to work in the same job, you're all from the same starting point. And I think what you really need for something to work is lots of different perspectives. Otherwise, nothing changes. Everything's done in the same way. It benefits a certain set of people. But in order for engineering is meant to be solving problems for everybody. You need everyone to be involved in that. Otherwise, you're missing out so much. So I mean, yeah, there is something for everybody, definitely. And what your experience is, you know, what interests you and what your expertise are. You don't have to be a certain type of person, because I think that rules out so much.
That's fantastic. May I ask what subjects you took, and what was your route into the job? Was it A levels and then university course? Is that what you did?
It was in a roundabout way, yeah.
Right. Okay.
So my A levels at school were a bit of a mixture. I did physics and I did music tech. I also did economics. Not sure why. Kind of thought it was a good idea at the time.
Well, you must have had an interest.
Wasn't really for me. It was great, but it wasn't for me. And I studied German as well, because I liked it. And from there, it was then I went to look at university courses and realised that actually, with the physics and with the music tech, I really should have done maths. But at the time, that wasn't really discussed. So I took an extra year to do maths and did that, and then went to university to study music technology. And it was through that I found out about acoustics, because I'd not really heard of it before. So looking at acoustics, I thought, okay, maybe I can do a master's degree in that and specialise in that. But because the course I'd done didn't have a lot of maths in it, I then went and studied maths a little bit further before then doing the master's. So yeah, I never really kind of wanted to jump into a maths course, but kind of as and when I needed it, I thought I need to top this up. I need to understand a little bit more about what I'm doing to back up the theory. So it was a kind of a piece by piece thing. And from there, yeah, after doing a master's, was then got a graduate position with Ramboll, actually, and this is where I've been working since.
Right, and
yeah.
I think that's a really good point to raise, that you did, as you say, loop back round and do maths for another year.
Yeah,
you can change your mind. You can
all the time. Yeah. Even now, still.
Yeah, we're all still figuring things out.
Yeah, I mean, it's so, when you're 16 to decide what you want to do as a career in 10 years' time, it's a bit of a daft question. In my experience, it's like, well, I know what I like now, I'll do that. And from there, in my experience anyway, you find out about other things and you think, okay, I'll have a look at that. And, some people are very focused and that's great. Other people just kind of find their way, which is what I did.
And do you work with other people who've taken different routes, like apprenticeships and things like that? Yeah,
more and more so now, actually. Apprenticeships are becoming far more accessible, I think, and there's more of them. I know certainly with the Institute of Acoustics, who is my professional institution, they run apprenticeship schemes. So yeah, it's not necessarily university route is not for everybody, certainly, and it doesn't have to be. there's many different ways into it. I work with people who've perhaps been working for the company in a different position, different role, and then through there has been trained on the job in engineering. So not necessarily even started out meaning to do that, but just kind of got enveloped by it and took on the position from there. So yeah, definitely there's not one route into it, and I think it's perhaps better that there aren't, because again, if that's the case, then you just get the same kind of person doing the job all the time, and you don't need that. That's not good.
That's absolutely wonderful. Thank you so much. I think we have come to the end of the session. So Rachel, thank you so much for speaking with us today, and to everybody for watching. Thank you for your attention. We hope you found this session informative and useful. Rachel, any final words from yourself?
Well, thank you for listening, and you're most welcome. Again, if it is something you're interested in, please look at the Institute of Acoustics website. Otherwise, engineering in general, yeah, go find out more about it. There's a lot more than meets the eye.
That's brilliant. Thank you ever so much. Don't forget, you can find out lots more about careers and options on the GMACS website, gmacs.co.uk. But other than that, thank you very much for joining us. Goodbye for now.